A new public service announcement on nuclear readiness was released this summer by the New York City Emergency Management Division, instructing New Yorkers on what to do in the event of a nuclear attack. The 90-second film opens with a woman casually breaking the terrible news, so there was a nuclear assault. I won't tell you how or why, just know that it's happened. The PSA then instructs New Yorkers on what to do if a nuclear attack occurs: enter, remain inside, and keep up with news and governmental changes. However, being nuclear prepared is more effective if you are not within a nuclear attack's explosion zone. Otherwise, you won't be able to enter your home to lock the doors since it would be gone. Imagine there were hundreds of those large ones in all. Even a small nuclear war would consist of that. If you're fortunate enough to be outside of one of those explosion zones, it might not spoil your day, but it will eventually wreck your entire existence. A single nuclear explosion's effects. The radiation, heat, and blast impacts of any nuclear detonation cause numerous instantaneous fatalities. The initial result of a nuclear weapon explosion is direct radiation. It is generated by nuclear events inside the bomb and mostly manifests as neutrons and gamma rays. A modern nuclear weapon with an explosive yield equivalent to the effect of several hundred kilotons of TNT explodes in less than a second, but the fatal radiation level can travel over a mile in all directions. When a nuclear weapon explodes, energy released in the form of X-rays heats the immediate area, creating a firestorm of extremely hot air. Like the sun's multi-million-degree core, the fireball's interior is so hot and pressure is so intense that all matter is reduced to a hot plasma of bare nuclei and subatomic particles. The fireball that results from the airburst explosion of a 300-kiloton nuclear weapon, such as the thermonuclear warhead W-87 that is currently mounted on Minuteman III missiles in the U.S. nuclear arsenal, can reach a diameter of more than 600 meters, 2,000 feet, and remain blindingly bright for several seconds before its surface cools. Moreover, 1/3 of the explosive energy of the thermonuclear weapon will be released as light from the fireball, which will be so powerful that it ignites flames and produces serious burns at a vast distance. A 300-kiloton nuclear weapon's thermal flash might result in first-degree burns up to 13 kilometers, 8 miles, from the explosion site. Then the blast wave arrives. The blast wave, which makes up about half of the explosive energy of the bomb, first moves faster than the speed of sound, but quickly slows down as it passes through the atmosphere and loses energy. Air in the vicinity expands and is pushed quickly outward as a result of the radiation superheating of the atmosphere around the fireball. This shockwave pushes against anything in its path and has immense destructive potential. The explosive yield of the weapon and burst altitude both affect how damaging the blast wave is. Up to 4.7 kilometers, 2.9 miles, from the target, a 300-kiloton airburst explosion would produce a blast with an overpressure of over 5 pounds per square inch, or 0.3 atmospheres. Within 10 seconds of the explosion, this kind of pressure is sufficient to obliterate the majority of homes, gut skyscrapers, and result in numerous fatalities. Radiation contamination. The fireball starts to cool and ascend, eventually developing into the familiar mushroom cloud's head, not long after the nuclear detonation has expended the majority of its energy in the direct radiation, heat, and blast. The cloud contains a highly radioactive mixture of split atoms that will soon start to fall out when it is driven by the wind. Post-war survivors will be exposed to amounts of ionizing radiation that are almost fatal due to radioactive fallout, a type of delayed radioactivity. Regarding the explosion, the fission yield of the bomb and the height of its burst determine the severity of the fallout contamination. The initial danger zone for weapons with a lethal yield can extend thousands of square kilometers downwind of the blast site. Short half-life isotopes, which are the most energetic and thus most harmful to biological systems, will first dominate radiation levels. Authorities advise staying indoors for at least 48 hours to allow radiation levels to drop because the acutely fatal consequences of the fallout would continue for days to weeks. Estimating casualties from the fallout is challenging due to its relatively delayed impacts. The number of fatalities and injuries will heavily depend on what people do in the aftermath of an explosion. However, when an explosion occurs, nearby structures would entirely collapse, making it impossible for survivors to find cover. Those who survive a nuclear explosion with a yield of 300 kilotons will be exposed to 500 Röntgen-equivalent man-hours of ionizing radiation, REM. The U.S. Nuclear Regulatory Commission states that it is generally accepted that persons exposed to around 500 rem of radiation all at once will probably die without medical treatment. A 300 kiloton nuclear explosion, however, would almost surely burn and crush any human at such a near distance from ground zero. The acute radiation zone is less compared to other immediate impacts of a nuclear weapon with a higher yield. In the first 24 hours following the explosion, a 300 kiloton nuclear warhead detonated on a city like New York would result in over 1 million fatalities and roughly twice as many people suffering serious injuries. This is equivalent to a warhead with nearly 10 times the power of the atomic bombs dropped on Hiroshima and Nagasaki combined. Around the explosion site, a few kilometers away, there would be almost no survivors. Repercussions of nuclear war right away. In a nuclear conflict, hundreds or thousands of explosions would take place minutes apart. 27 million people would die directly from a regional nuclear conflict between India and Pakistan that involved around 100 nuclear weapons with a 15 kiloton bomb. At least 360 million people would die quickly if the United States and Russia launched a worldwide nuclear war with more than 4,100 kiloton weapons. That is roughly 30 million more individuals than live in the United States as a whole. Based on the 2002 Strategic Offensive Reductions Treaty, SORT, restrictions, which allow for the deployment of up to 2,200 strategic warheads by each nation, this estimate assumes that Russia and the United States will engage in an all-out nuclear conflict with 4,400 100 kiloton missiles. The 2010 New START Treaty substantially reduced the number of long-range nuclear warheads that the US and Russia may deploy. However, given that the average yield of Russia's and the United States strategic nuclear arsenals already exceeds 100 kilotons, a complete nuclear war between the two nations involving about 3,000 warheads would probably cause comparable direct casualties and soot emissions. In a full-scale nuclear conflict, Russia and the United States would not only launch nuclear missiles at one another's countries of origin, but also attack other nations, including those that also possess nuclear weapons. These nations could use any or all of their arsenals to retaliate. Currently, it is thought that the United States, China, France, Israel, India, Pakistan, and North Korea collectively possess more than 1,200 nuclear bombs. Even with those horrifying numbers, the tens to hundreds of millions of people who perish or are injured in the first few days of a nuclear war would merely be the beginning of a calamity that will gradually affect the entire planet. Survivors of a nuclear war might have to live with extensive societal collapse, widespread radioactive contamination, and global climatic shifts for many years. Any nuclear conflict, no matter how big or small, could result in a 2-year famine that is more lethal than the war's many bomb explosions combined by a factor of more than 10. The long-term effects of nuclear conflict. There has been a rising belief in some military and policy circles in the U.S. in recent years that a limited nuclear conflict can be waged and won. However, a limited nuclear conflict is unlikely to stay limited, according to many experts. An all-out nuclear conflict that begins with a single tactical nuclear strike or a tit-for-tat nuclear exchange between two nations could result in the immediate and complete destruction of both nations. However, the calamity won't just affect those two combatants and their allies. The horrifying, visible local repercussions of nuclear explosions have obscured the long-term regional and global effects in public discussions. Due to their responsibility for determining the effectiveness of nuclear forces against both military and civilian targets, military planners have also concentrated on the immediate consequences of nuclear explosions. From a military standpoint, the deployment of nuclear bombs is intended to cause blast, localized radioactive fallout, and electromagnetic pulse, and powerful bursts of radio waves that can harm electronic equipment. However, the extensive fires and other climatic changes brought on by several nuclear explosions might not be taken into account in war strategies and nuclear doctrines. These unintended consequences are challenging to foresee, and evaluating them needs scientific expertise that the majority of military planners do not have or take into account. However, such collateral damage may result in the deaths of more than half of Earth's population within a few years of a nuclear conflict. That was for today. Thank you for staying with us. Don't forget to like our video and subscribe to our channel.